This is geometry. I'm going to do a couple of examples of word problems that have to do with finding either side lengths or angles using trigonometry. I was going to say trigonometry. If it's looking for an angle, you're going to have to use the inverse trigonometric functions: arc sine, arc cosine, arc tangent. On a TI-84, it's hit the second button. If you hit second, it's a blue button, and then sine, it'll give you arc sine. The sine of an angle gives a ratio. The arc sine of a ratio gives an angle. Same thing with tangent and cosine. All right, a wire goes from the top of a tower that is 40 feet high. So I'm going to always, step one, draw the situation so you can see what's going on. Top of a tower, here's 40-foot high tower, and is anchored to the ground. Here's the wire. It's anchored to the ground. It says angle of depression. Angle of elevation and angle of depression are always from horizontal. So here's the horizontal, and here's the angle of depression, which is 64. I'll make that a little thicker. 64. Now it's too thick. I can't get the exact perfect. All right, 64 degrees is the angle of depression. And it wants me to find the length of the wire. So the wire is X. All right, so there's two ways to do that, to do this. I could either redraw the height here, which is 40, and now I'm looking for that length, and there's 64 degrees. So I have the opposite, and I have the hypotenuse. So opposite and hypotenuse is sine. Sine of 64 degrees. I guess I just can't get it exactly as thick as I want. It's either too thin or too thick. 64 degrees equals 40 divided by x. I will multiply both sides by x and divide both sides by 64. I get x equals 40 divided by sine 64 degrees. Now I'll show in a moment that both of these ways are going to get the same answer. I could also just use the triangle I have, and if this whole angle is 90, so if the top part is 64, what's left on the inside of that left-handed triangle? 90 minus 64, 64, 74, 84, so 26 degrees. So instead of sine, now I have adjacent. 40 is now adjacent there, and the hypotenuse. So I can do cosine of 60, not 64, I was about to write 64. Cosine of 26 degrees equals 40 over x. Then I'm going to multiply both sides by x and divide both sides by 40, and I don't have enough room to do it. I guess I'll write it down here. X is going to multiply up here. Cosine is going to divide. So x equals 40 divided by cosine 64 degrees. And both of those answers, whether I make an imaginary triangle to the right and I realize that the height is still 40 and I'm still looking for the hypotenuse. So I'm going to show on Desmos that both of those are going to be the same. 40 divided by sine 64, and then I have to check on your TI-84, make sure you're in degree mode. I'm in degree mode. And then I do 40 divided by cosine. What was it? Oops, cosine. Was it 26? 26 degrees. And you'll see it comes out to the same, 44.5. I don't know, it doesn't say what to round, so I'm just going to round it to one decimal place, 44.5. Well, everything's in whole feet, so this is 44.504. It's a little bit bigger than 5, so I'm going to round it to the whole number. 45 feet, approximately, is the height or the length of that wire. All right, let me do another one. Here's a nice looking one. Let me get some room so I can zoom in on it the proper way. This one says for questions, boy, I can't get rid of those menus. 12 to 24, Lindsay shouts down to Pete from her third-story window. So this must be Lindsay up here, and this must be Pete. And if she says it again, he'll be repeat. That's a joke. All right, so here's the first one. Lindsay is 9.2 meters high. That's it shows. And the angle of depression from Lindsay to Pete is 79 degrees. So notice how in the picture, the angle of depression, I'll do it in red, is shown from the horizontal, and it's 79 degrees. I know it's a little blurry, but do the best we can. Find the distance from peak to the base of the building. So I want this. And so on this one, let me zoom in so I can really see it. On this one, I know the height is 9.2 meters. So this is 9.2 meters. And on this one, I have to find this angle because, well, I guess I could redraw the triangle up here and do it the same way. But I'm going to find that angle inside the triangle. Well, this whole thing's a right angle. If this part is 79 degrees, 90 minus 79, 11 degrees. So inside that triangle is 11 degrees. So what I have is this. This is 11. This is 9.2. And I need to find x. Well, what do I have? I have opposite and adjacent. That's tangent. Tangent, 11 degrees, equals opposite, which is x, divided by adjacent, which is 9.2. Multiply both sides by 9.2. 9.2 times tangent, 11 degrees, is going to equal x. And let me see, does it say what I have to round to? Let's see what I have to round to. Find the distance. It doesn't say. So I'll just, let's see, it gives 9.2. I'll round it to the nearest tenth. And so now I'm going to put that in there. 9.2. 9.2 times tangent, 11 degrees. 9.2 tangent, 11 degrees. I will make sure that I am in degree mode, which I am. That's 1.8, approximately 1.8 meters is his distance. All right, let me do two more. That's finding length. So notice with lengths, I use sine, I use tangent. I'm going to do a couple where I find the angle. All right, this one says, because of the pitch of an attic's roof, a bookcase that is 5 feet high should be placed as shown. What is the measure of the angle formed by the roof and the floor? So notice this is a triangle, and it's a right triangle, and I'm looking for this angle x, and I have the opposite 5 feet and the adjacent. So tangent, x degrees, equals opposite over adjacent. Well, if I'm looking for the angle, I have to use the arctangent. On your TI-84, it's going to be the blue button second, and then press tangent, and then put in the 5 over 12. So I'm going to do arctangent. So x degrees equals arctangent. On the TI-84, it's tan minus 1. After second, you'll see just above the tangent button, it says tan minus 1, 5/12. And again, I have to make sure I'm in degree mode if I'm going to think the answer is in degrees. But I'm going to do arc tan 5/12. And it comes out to 22.6. It doesn't say, there's nothing there about rounding. If there is an instruction to round it that way. I'm going to round it to the nearest whole degree because everything, it's 5 feet, 12 feet. So I'm going to do 23, approximately 23 degrees. All right, let me do one more where I have to find the angle. Find the angle of elevation that a 30-foot ladder leaning against a wall. Okay, here's the ladder, and here's the wall. This will be the ladder. And it's a 30-foot ladder. And here will be the angle of elevation from the horizontal. Makes a 90-degree angle. The wall makes a 90-degree angle. Leaning against a wall, if the bottom of the ladder is 9 feet away. So the length of the ladder is 30 feet, and the bottom of the ladder is 9 feet away, and I want this, the angle of elevation. Well, what do I have? I have adjacent and hypotenuse. So I'm going to do cosine. Cosine of whatever that angle is, the angle of elevation, equals adjacent over hypotenuse. And now I need to find the angle, so it's going to be x equals arc cosine. 9/30. And again, I will round it to the nearest whole number. Arc cosine 9/30. Whoops, I didn't want that in all caps. 9 over 30. I will make sure that I am in degree mode. 72.542, well, approximately 73 degrees. So that's it. When you're looking for an angle, you're going to have to use those inverse functions. When you're looking for a side length, you just use the trigonometric functions. But that's a few examples of how to find side lengths and angles using trigonometry, the trigonometric ratios and the inverse trigonometric functions.